Well, welcome everybody to this webinar. My name is David from Vortex, based in Austin, Texas. And maybe Edwald, can you skip the next slide, please? Yeah, this is basically about what we will explain. Next slide, please. I think it's better if Edwald, you start with these few first slides and then I jump into, because I think the first will tell more or less how it will work rather than I start, right? Okay, thank you.
That's fine. Thank you, David. And thank you for taking the time of joining us. I know it's very early your time. Is it Pacific time you're in? So I hope you have a cup of coffee or something during today.
Thank you.
But anyway, just to show a little bit and to recap after the last webinar we held last week. So the idea of today is essentially we're going to view a little bit on how the two platforms work and collaborate together. We have spent quite a lot of time actually optimizing the processes of actually evaluating and estimating making the most optimal immediate suitability reporting for offshore wind farms. And we believe that this sort of process we're about to show you today will not only help you a lot in actually in sort of day-to-day work, but this will actually optimize the process and accelerate offshore wind. So one of the things we want to display is actually how actually that's done, and we'll do that together with showing the platform and how that works. But just to recap, so we actually have aligned with Vortex and implemented their sort of link to our platform, and Vortex has the most accurate synthetic wind resource data actually to be used prior to wind measurements. But then we sort of asked us a questions: what should we do with these valuable data sets, and how can we make sure that this is sort of utilized in the most optimal and easy way? So Youwind then basically is a platform that gathers these data sets. It optimizes basically where's the best location for my wind farm, what turbines is the best one actually for my project, and which capacity will provide the lowest LCOE, which sort of technologies can be used, which sort of foundations are the most cost economic. And basically with the high quality wind data assessments we have both for synthetic data from ERA 5 or ERA 2 or other data sources, how can we make sure that with measurements we can actually calculate bankable yield assessments? And that has been basically the work we've been ongoing now for several years now within the Vortex team. So as a summary, so the input data are basically site-specific data sets. We combine them with spatial data, which are GIS layers, environmental, technical, and human constraints that you would have for any site that the user might be assessing. And then together with that, we combine that with different engineering sub-functions, for example, calculating the yield, calculating the layout, calculating the array cable lengths, the export cable lengths, so on and so forth. And then obviously combining everything with our overall cost functions of both the development costs, but also the capital costs and the operational costs. And together with this, we actually make sure that we calculate in a very easy and intuitive way what is the actual energy production in terms of a P50 and P90, what's the optimal layout, what sort of reporting can be done, what sort of data can be exported for further evaluations. And with this, we make sure that all sort of data is combined, it's visualized, is analyzed, and can be easily benchmarked with different projects, and that the user can basically use to optimize their overall wind farm and can do it in a very easy way. So, but before we actually dive into the platform, I will let David actually present in more detail Vortex and basically what they work with. So go ahead, David.
Okay, yeah, now it's my turn. Basically, Vortex, we are a private-owned company since 2005 with our headquarters in Barcelona. And we have solutions for the different stages in the wind farm development. And basically, we are an online atmospheric modeling. And here in this link, you can just feel free to sign up for a user account, and you will see a lot of our free material, free data, and obviously others that are not free that you can use, not just for offshore, but for different wind farm projects. We address this with both the technical insight and also for asset performance management. And then we can provide as you say here, are the global estimations of wind at different periods and different sites in the world, especially when there are no measurements. So one of the things, or one of the constraints in the offshore industry, is that it's not easy to have measurements because met towers or floating lidars are not that easy and not that cheap to implement. Okay, next slide, please. As I said, here are all the different products from Vortex. Basically, we've been historically focused on hindcast solutions, which means that we look backwards and we have an idea of the wind conditions in a site for the last, let's say, 30 to 40 years in any site of the world. But lately we have had two spin-offs, which are Climate Scale and Sirocco Energy, which they go forecast. And Sirocco Energy is for the short-term forecasts for the next 15 days for energy trading and stuff. Then we have Climate Scale, which is for the long-term effects of the climate change, not just in the wind industry, but in many others. But since we started in the wind industry, this is where we have our first clients out there. And then somewhere in between, we have Sirocco, Seasonal, which is that logo you can see in the right-hand side. And Seasonal is again a solution developed by Vortex that covers this gap in between the next 15 days and up to 1 year. And we have we give different patterns, different trends of this wind conditions in a site, again, either onshore or offshore. Next slide, please. But going to the detail about the offshore projects and solutions. Next slide. Okay, yeah, we have first of all the series. It's maybe our best-selling product. Is this what we are well known for? It's a long time series that it can cover from the last 10 to almost 40 years. And what is important is that we offer all height from 50 up to 30 meters, 300 meters, excuse me, so you can see about the wind shear in your site. But the Vortex series is at the specific spot, so we need to know the lat and long coordinates, and then we can pull out this time series, which basically are for when developers have, let's say, a few months of measurements. Why not also in offshore, although it's not that easy, as I said before. Then we can use them to extrapolate these few months of measurements to the long term, so you can have an idea of your 6 months or 1 year of measurements, how it can be during a long period of time. Okay, it's an hourly timestamp and it's at 3 kilometers horizontal resolution. We offer 3 reanalysis data sets, basically the ERA 5, CFSR, and MERA 2. But let me tell you that in the last 3-4 years, I mean, I would say 90% of our clients, they go to ERA 5, which is, it seems to be a consensus in consensus in the wind industry that it's the one that matches better the atmospheric conditions in a site. Next slide, please. We also have a time series, which is the Vortex LES. This is not for the long term. This is just 1 year of time series. Again, it's in a single spot. And differently to series that we talked before, this is a 10 minutes time stamp. So this is the nearest thing that you can find to a met mast. You would have with Vortex LES the same kind of data that you will be pulling out from a data logger. Again, all height from 50 to 300 meters. And the important thing here is that you have information about the standard deviation for both wind speed and wind direction, 3-second gust, and many other deliverables. And Vortex LES, I would say this is to know the turbulence intensity conditions in a site, the ambient turbulence intensity, right? And again, very important, this is simulated at 100 meters resolution, horizontal resolution. The time series before it was 3 kilometers, this is 100 meters. Next slide, please. And then we have talked about single spots. Both series and LES are at the single spot. And now we go to a couple of products that covers a large area. The first one is a farm, which is a high resolution map at 100 meters horizontal resolution. And we can cover a large area up to 2,000 square kilometers. I know that this is a size that maybe in the US is not that large, but we're working on that to be able to increase these areas. And basically what we pull out is a WRG file that tells you about the wind conditions in the whole area. And it can be calibrated with measurements. So whenever, that's because it all started with onshore, where it's more likely to have measurements. When there are measurements, we can remodel, so we can enhance the accuracy of the map by using the measurements. This is optional. If users want to do that, that's fine. The thing with the farm is that it contains no information about the time, right? This is just, it's all collapsed, so it's just a WRG file. We were asked by many clients that they would like to have a farm with time series, with time information. And this is why we developed the next slide, which is called blocks. And blocks, long story short, this is a farm, so a WRG with gridded time series. So it means that you have a large area. Here it says 1,500 square kilometers, but it can go up to 2,000 like farm. And at each grid point, you would have 1 year of 30 minutes time series, which is something that is very useful nowadays, that the market conditions for energy trading, for example, prices are different. So with blocks, you would be able to filter the WRG, for example, between day and night, because as we all know, the wind conditions are different from day to night. Or for example, winter, summer, again, there are many differences. Or you can even filter for the stability conditions, which is something that's an example that could be useful for energy trading again. Again, the deliverables are WRG, GIS filters and layers. And again, you can filter by many options. And I think basically this is it. We can go to the next slide, please. Just wrapping up, that Vortex, we have experience in almost every region of the world in offshore, basically in Europe. That's where it all started. Then our 4 products that are basically for this offshore, again, Sirius and LES, single spot. And then the ones that covers a large area, farm with no information on time, and blocks, which is a farm with gridded time series in the domain. We can even customize different solutions. I'm not going through this right now, but if you have any requests of any specific product that you cannot see here or in our interface, just let us know and we'll try to customize some solutions for you. And we have validated not just these 4 products, but all of our portfolio. We have many documents with validations that were run not just by Vortex, but also by third parties. And in our knowledge center, which you can see the link here below, you will find technical documents and all these validations that I was talking about. And I think this is it. So next slide. Oh yeah, just summarize of the US market. As you can see here, this is from the Department of Energy in the US. This is going to grow, but absolutely. As you can see now, there's just 42 megawatts installed, basically in Block Island wind farm with 5 turbines. But if you read the first sentence, the target, it's to go up to 30 gigawatts by 2030 and going up to 110 by 2050, which is a lot. That's a challenging. So it's all starting right now. Next slide, please. And focusing, next slide. Okay, and focusing on this, the topic for this webinar that now my colleagues at Youwind will go into detail. The California lease area, it's about, there's 5 areas divided in 2, in the North Coast, in the Central Coast. I think we will focus on the Morro Bay, which is in the Central Coast. And this is up for 4.6 gigawatts, right? Although they say that development capacity could be as high as 7.5, but we should start thinking that it's going to be 4.6 gigawatts. And next and final slide by Vortex. The timeline, yeah, it was issued, it was released on October the 18th this year, right? And it will be the December the 5th. It's like a kind of a online mock auction for the potential bidders. But really the important one, it will take place the very next day, so December 6th, 7 a.m. Pacific Standard Time. So that's when the real auction will take place. And I know if any of our attendants in this webinar, they will go and bid. I wish you luck, and I hope that you will need Vortex data for this project. And I think this is it from Vortex side. So Edwell and Peter, you can continue, please.
Thank you very much, David. That was very informative, especially around the market here in California, and actually the goal of US over the next 30 or so years. 110 gigawatts is an incredibly ambitious goal. So I hope we're at the right time to come here with the right data sets and right tools actually to help accelerating this process. So it's a great collaboration here with these two companies. What I will do now is I'll present a little bit how basically the Youwind platform works, and actually how we use a series product from Vortex actually to calculate the wind resource for our projects. And I'm here with my colleague Peter as well, that will also jump in with some comments. So take this as me just guiding you a little bit through the platform and explaining a little bit in more detail how the platform works. And I would also remind everyone to write down a question if you have one during this presentation. It's very nice to have question feedback from the users actually on this webinar. So feel free to write any question in the Q&A window, and we'll make sure in the end of this presentation to answer all of them. So just as a very brief summary. So when you enter first to the Youwind platform, it looks like this. This is basically the dashboard of the different sort of projects we have been working on. So here I have a company profile with my colleague Peter here, or users in my company. This is basically the dashboard where I can invite new users, or I can disable user login, or what it may be actually for me as an admin to control the different inputs and users to the platform. What is also very important here is that for the users of the platform, the idea with Youwind is not only the optimization and calculations of offshore wind farms, but it's also the collaboration between colleagues. So, for example, between different departments, especially in bigger companies, it's very important that sort of everyone is aligned with the different scenarios that we're working on, and the different inputs that are needed for the different specialists, etc. So, for example, here you can add a comment to a different foundation or different turbine. The comment, you can actually go back and forth and revise, and you can always see what is sort of the different inputs and outputs. And this, for example, is a change that I've made. And for each change, there is a change log as well. So it's all very easy for the admin to see what has been changed and when. And this is very useful for companies actually to evaluate and to see and trace basically what has been done and why. So this is sort of the collaboration part of the platform. If I enter basically and go over a typical library, and basically the inputs of the Youwind platform and the architecture is a library. So essentially it's a build by a Lego block where you're building together the different components of an offshore wind farm. And for each sort of part of library, we have a preset. Now, these presets are a basic evaluation from the Youwind team from using public sources, amongst others, data from NREL, DTU, and other data sources that are officially available to evaluate what is more or less cost of a turbine for this particular location, how much will the turbine weigh, what is the overall rotor diameter, for example, and how much might this turbine produce in case it was actually installed at a particular location. So here you can, for example, see a library for the different offshore wind turbines. And if you look at, for example, this one that has been evaluated by us for this particular webinar, then this is a turbine we basically scaled up from the 15 megawatt turbine from NREL, and we sort of evaluated the different power and thrust curves to be used actually for the AEP calculations. So for different library components, there are always inputs. There are basically preset libraries, but the users can always add their own inputs, meaning if there is a power curve that is coming from a user that they want to evaluate for a different project, then they can essentially add that in, and that data is only shared by the users who are part of this company profile. So none of the data is shared with anyone else outside. This is something we've been working quite a long time of actually getting done correctly, so the security essentially not only for cyber attacks but also for data protection is very high in stake. So when you enter a typical project, and this, for example, is the Morro Bay project we're going to evaluate today, then basically all these different components here on the left side, you can see, are coming straight from the library. So for example, here you have the project analysis by project name. You can evaluate the different site details. This, for example, is the actual site that we have. Here we have imported the data sets from the Vortex platform only for at a macro level, only for this particular location. And then we've also added the bathymetry for this particular site, ground conditions, etc. So for particular site, you basically will decide actually also what sort of capacity you want to evaluate as a part of your wind farm. And as apart from that, you basically start adding on the different Lego blocks. Basically, what sort of turbine do you want to use? What sort of foundations, array cables, export cables, and so on and so forth. So for this particular turbine here, that we evaluated, then we can go back here and you can see evaluate that directly, or you can change, for example, the pricing or the power curve, and then from that you can essentially use that for your calculations.
Yeah, let me just add, also responding to a question here that from Charles online, that we have also several engineering and cost modeling functions for different foundations, including floating foundations and different mooring types. So that is in addition to your turbine, you can enter parameters, and there's also engineering functions behind this for calculating the cost of floating installations.
Yep, thanks for that. But as Peter was mentioning, so for example here, while adding the turbine, adding the foundation, so for this particular wind farm, the water depth is quite deep. So we've chosen as an evaluation here a TLP solution with a TLP mooring system or a tension leg mooring system type for mooring lines. And this is basically the overall cost we evaluate for that. And sort of all these sort of inputs we also add into calculating what are the overall foundation weights. And this foundation weight is then a function of the logistical setup, the bathymetry, and the ground conditions. Same for array cables. That's basically a function of how big is your wind farm. And we calculate the array cable lengths and the export cable lengths, and so on and so forth. So all these sort of parts are inbuilt as an engineering function within your offshore wind farm. So when you've chosen all these inputs, particularly for this site, you want to say, I want to evaluate for all these components, what sort of part of the areas are interesting for me. Now, in particular, what we combine here is a GIS or spatial platform, basically looking into what are sort of different sort of requirements for or restrictions based on environment, based on human restrictions, etc., for my particular location. So what we are also working with is offering a service on making sure that all these sort of official data sets are a part of the platform, meaning that we are saving the time of not only getting the wind data or the cost data or the technical data actually inside, we're also enabling the users to have all the other environmental restrictions inside. So we enable the user to get access to, for example, to vessel traffic for particular locations, different submarine array areas. So by this, all the users can essentially see what exactly are my restrictions for the different locations. And with that, we can also see what sort of bathymetry do I have for the location, and so on and so forth. So the idea here is basically that the user enters the platform and has everything that they need to start evaluating and start optimizing the offshore wind farm and start accelerating the process before entering and before evaluating a sort of a manual process of getting different inputs, putting them in an Excel spreadsheet, using other programs to calculate yield. The idea here is that we have everything in one place. So when we have all these sort of restrictions in place, and for this particular location, we already have the polygons or the site areas that David was describing before for California. It is very easy to use. Basically, the way that the area screening works is that you can either draw up a single polygon, and we have an algorithm that splits up the polygon depending on how big you want the wind farm to be, and then you can sort of tweak the polygon on how do you want it, or you can simply just draw a polygon and get all the wind data, all the bathymetry data, all the ground condition data into one area, and then you can calculate what is my yield and what is my overall LCOE for this particular wind farm. So this is one part. Another part is basically you can also upload the layers, and this is what I've done here for the Morro Bay area. So basically these polygons are a part of this bid coming up here on December 6th. So by importing these, I can basically say I want to see what is the wind speed inside this particular area, and then this and this. And then with this color map here, I'm basically prioritizing which ones are the best ones. So going from the Humboldt area here in the north, basically seeing that the LCOE is slightly higher, taking everything into account. And bear in mind that it's also taking into account here the overall grid connections and the harbors. So we take into account the different harbors, distance to harbors, logistical setup, etc., but also distance to the different grid connections. So the calculations of export cable lengths, potential losses, availabilities, etc. So by taking all this into account, we would like to say, well, for this particular location, what actually is my site restriction, what actually are the overall costs, and actually what is the potential here for this particular site. So here on the left-hand side, you can see what is the size of the area. So this takes this particular polygon and calculates the site. We have gathered the wind data already here from Vortex and calculated and adapted that calculation actually to hub height. So we know exactly for this particular turbine that is 150 meter hub height, what is the mean wind speed at that height. And we calculate also the average water depth at this location, and then we guess also the windrows as a function. And basically here and below, you can also see the different evaluations from the different polygons, which ones are the best actual locations. And this can be used actually not only here in California, but actually worldwide, because we have data from all the data sources worldwide, not only for bathymetry and ground conditions but also wind speed with the maps provided by Vortex. But if we want to basically evaluate this particular wind farm, we can basically choose that one here and say, I want to make a layout, and then I'll show you how that works.
Yeah, maybe nice to note here also that what I mentioned before here, the bathymetry is also coupled to the cost modeling for different foundation types. So if you have deeper waters, the cost might be higher. But of course, that's a balance between yield and cost of the foundation or the mooring.
Yeah, exactly. So that's all part of basically this optimization procedure with a particular wind farm. But if we're looking at this at a polygon at a macro level, so why don't we just look at this basically on a micro level? So if we're choosing this particular area, for example, that we're choosing, we can also make a layout for this particular area. So by introducing the different parameters for optimizing a layout, we can basically choose if we want to make the first sort of layout for this particular polygon, a regular grid layout or a staggered grid. We can choose the different rotor diameter spacing between, and we can also choose the different wake model types. Here, for example, we have the NO Jensen calculation made. We can adapt the different wake expansion parameters with this model type. But we have also TurboPark as a part of this calculation procedure, which is the latest wake model actually published open source by Ørsted. That's a wake model has been validated with over 19 operating wind farms. So probably the most sort of calibrated wake model known today. So that's also part of this process that can be used actually to calculate. But not only that, we can basically say, when we make a layout, it's also calculated. Here you can see visually how the wake expansion and the wake tail is between the different turbines. That depends basically on the windrows. And here you can see basically what is the wake loss and what is the AEP after wake losses. Now, as apart from that, you can also get the elevation or the basically bathymetry per position for the different turbines. If you click this button here, then with the API we have, so for different positions, you have a different cost function with it, as Peter was mentioning. And while combining all this, and if we update all the project, then all the sort of cost function are part of each an individual turbine, which means that we are basically calculating the cost per turbine per position, which is very useful actually when evaluating the costs of the offshore wind farm. Now, this is the calculation done with variable distribution, nominal wind speeds. So what if we couple this basically to a time series? So basically here I have an access to the Vortex platform, and that's basically the platform as most users by Vortex know it. Here I'm just basically logged on with my text account. I've uploaded here a couple of KML files just to see how it is. Oh, now I got locked out. That's good, because that means the security is working on your platform, David. That's positive. So I got locked out. Now I got logged in again. So here I'm inside the area here for the Morro Bay. If I click this time series here, I can basically see all the time series here that I have for over the last 30 years at 150 meters. And the best part here is essentially that I can also implement this in my own area. So now we have a layout here for this center area here, and basically what you can see here is the same different areas as you can see from the Vortex platform. So all these data sets are now already here inside the Youwind. And if I just click on this one here, I basically get the exact time series that I just looked into from the Vortex platform. And now I can basically start evaluating what sort of other sort of technical details I can look into when actually evaluating the viability of the offshore wind farm. So here on the left-hand side, we basically have the time span of the time series. The average wind speed at 150 meters, you can see is slightly higher than the one we have with the variable distribution. You can see how the data height is and actually how the turbine height is as well. So here you can basically see the time series, as you can see, hourly time series, average per day. And here you can see basically the time series as a wind park power average per day. So we chose an average of, we chose a maximum capacity of installed capacity of 800 megawatts. So basically you can see here how that actually evolves through the time. And this is basically already going back to 92. Interesting here to see, if you are used to the North Sea, that how the different wind speeds are basically the opposite from the seasons in the North Sea. So the biggest time, the biggest sort of wind speeds you can see basically are in the spring and summer months. So if you look here, is that basically now if we combine all the cost functions from the libraries, we combine that with the capacity chosen, we combine that with the layout that was designed, and we combine that with the time series we now have from Vortex that was now imported, we can basically see what is my annual energy production for each and every year that was evaluated throughout this time series. So we're basically taking the layout, we're calculating the AEP after losses for each and every year. And this is very useful to see all the different fluctuations there are, and it's probably more realistic than only using the nominal wind speed for this particular location. For each and every year, we have a production. We're also taking, if you're imagining that you have all the costs sort of accumulated before entering and starting producing power, you will basically see here that is also connected with a cash flow that is connected with a time series. And we're using that basically to evaluate what is the difference between the nominal wind and the time series for each particular year. So in the AAP statistics here, you basically see what is the net P50 or P50 after wake losses when using a 20-year average ERA 5 dataset. And basically while taking that and using the same power curves, the same park power, and the same capacity and the same layout, what will actually be the P50 after weight losses using a time series?
Yeah, and this also ties in nicely with the question from Bose Sumantra online, that this is how we quantify the influence of variability on the calculations. So these kinds of calculations not only show you on the AEP, but then also finally on the cost, you can get more insight. And for every also for the weight loss simulations, for example, you can do sensitivity studies to particular parameter settings as part of your uncertainty analysis.
Yeah, exactly. So by evaluating this, we can also see what is the cash flow. You can compare the cumulative cash flow on if you're comparing it to a time series or on nominal wind, and you can see basically here the differences between. And by summing it all up, we basically have the seasonality of the production going per the hour of the day, and then per production of each month is basically useful when evaluating power prices, power purchase agreements, and so on and so forth. So we can always go back actually into the project overview and finance. We can change the different parameters in the finance tab. We can evaluate what are the different electricity prices, what are the prognoses for electricity prices, and we can run different scenarios on actually how we could see that with the time series, how that will sort of expand. And this basically was a very, very brief summary of the platform using the Vortex time series, which we're very happy to have implemented. And I would have probably enjoyed talking here for a longer time, but it's time for Q&A.
Yeah, thank you very much, all of you, Edvald, David, and Peter. It was very interesting. We have some questions that Peter already answered some of them while you were talking, Edvald. So, but we still have like 7 questions here. The first one, if you like, I can read the question and you can answer, but is have you assessed the utility of Morro Bay data for offshore wind data validation or other purposes?
Well, for this particular scenario, we haven't known, but that's actually a part of a possibility to upload the measured data into the Vortex platform and to get a calibrated data set directly with a long-term time series. Then that time series can be utilized actually for these purposes of making layout and calculating the yield inside the Youwind platform.
Oh, thank you. Akiko is also asking, how is the accuracy in the cases with offshore, onshore, complex terrain and coastal area? Did you validate them with the measurement data? I don't know if this question is for Vortex or for Youwind, Akiko.
Sounds like Vortex.
Yeah.
Well, Akiko is especially interested in the case with Vortex LES, so I guess this is
Okay.
the clarification.
That's for me. Let me see if I can share my screen, and I'll show you. Let me see what I have, because I have a document about Vortex LES. No, so sorry. I don't know if you can see my screen with the technical validation of Vortex LES. Can you see it?
We cannot see it, David.
Okay, let me see. Screen share. How about that?
Yeah, we are not seeing. Yeah.
Can you see this?
Yeah, we can see the document. Yes.
Okay. This is for any one of you that might be interested. This is a documentation. It is in our knowledge center. Is this a document about the validation for offshore sites? This is, I think it's very relevant. It's interesting. And if you go through this document where we explain about the technology and LES, you will see that we have validated 18 sites. These are the ones. Unfortunately, they're just 2 in the US area, because again, our problem is to find data or measurements that are accessible so we can validate our LES. And here, these 18 sites, You can see that we validated the wind speed in all of them, but not the standard deviation because the data was not available. So the turbulence intensity, which is the key thing for LES, was just validated in 5 of these sites. And going to the metrics to answer the question, which is basically, we have some metrics, the mean standard error, mean absolute, and root mean square error. But the thing here is that if you see of the 18 sites, the absolute error is about 3%, right? We have some tendency to underestimate the wind resource, but again, long story short, again, mean absolute error 3.06%, right? Here you have some more metrics, depending on which one are you interested in. You can have access to this document. But for example, you see the correlation, you see it in 10 minutes, hourly, daily, or monthly, which if you see these values here, I think they're pretty good. But again, this is something that you can go through if you download this document.
Perfect. Thank you, David. I will send you all these documents at the end of the webinar. So tomorrow or the day after tomorrow, probably, I will send you the slides of the presentation and also the webinar recording, and as well as these documents that this document that David just showed you. Let's continue with the questions. We have another question here for Edvald or Peter. Is Youwind available for other regions in the world, like for example, Middle East?
Yes, it's available worldwide, also including the mapping, other restrictions, and wind and site data, basically.
Thanks. Ophélie Laurent is asking, do you have free limited access on Youwind to be able to test the platform?
Yeah, we have any user can basically sign up and have a free trial and see how it works. That's basically done if you go through the website. You can sign up for a free trial and have a test run.
Perfect. And Voce Sumantra is asking, how do you model O&M cost, component failure rates, etc., as part of LCOE calculation?
So we've used various different sources on evaluating the costs as a function of different potential failure rates, but we also use OptiWindow, which is our optimization logistical platform, where we go into and evaluate the different availabilities depending on vessels and depending on basically when and when potential failures can happen. So all this sort of in a more detailed simulation done inside the platform as a part of the O&M cost function.
Thank you, Edvald. We are actually running out of time, but let's answer a couple of questions more, and the other question that cannot be answered now, we will send the answers at the end of the webinar. So we'll get all the questions and we will answer them and send you the document to all of you, of course. But let's finish with a couple of questions more. Do you run wake losses based on time series?
Yeah, so thank you for that question. So when you load a time series from Vortex into Youwind platform, you can use your layout indeed, and then for each time sample we evaluate the wake losses based on the current wind conditions, and you can run through this time series for up to 30 years, like you saw before, in the order of minutes. So yes, and you can also switch between different wake loss models then.
Perfect. So, and the last one for today, how do you estimate the F&D cost, both supply and installation, based on the ground conditions?
Yeah, that's a good question. That also differs between if it's a fixed bottom or floating platform, but we have a function that enables the engineering calculations to evaluate if it's sandy, muddy, or clay, or very rocky area. Then we have a simple function that calculates a different cost based on the potential additional installation costs, and both in installation and in fabrication. So it's a very sort of simple engineering function that applies to that. But all these inputs, like with the turbines, like with the sites and others, can be adapted by the users. So you can add different sensibilities, different costs, etc., depending on the locations you're evaluating.
Okay, perfect. Thank you very much, Edvald. Thank you, Peter. Thank you, David. And thank you all attendees for joining us today to the webinar. We still have 3 more questions to be answered, but as I say, we will answer all the questions that you sent us here today to all of you, so you can have the answers in a document, and we will also send the slides and the webinar recording. And again, thank you very much for joining us today.
Thanks. It's been a pleasure.
Thanks a lot. Pleasure. Have a nice day.
Thank you.
Have a nice day, you too.
Bye-bye.